Welcome back to the Moonbuilders Workshop series. Thank you so much for joining us. Today, I have the incredible pleasure to be joined by Chris Lee from Oak Network. Now, Oak Network, you've probably already heard of it, but I'm going to give you a quick introduction and just a recap before we get things started. So Oak Network stands for On-Chain Autonomous Kernel, and it's a layer 1 blockchain that enables you to build multi-chain applications to automate single or recurring transactions using a simple if this trigger condition and a then that transaction instruction. Oak Network is designed to be a Web3 hub for cross-chain automation, and it unlocks a huge range of rich DeFi user experiences, including scheduled and recurring payments, stable cost averaging, stop loss and limit orders, and non-custodial copy trading. Oak Network and Moonbeam are very well integrated within XCM collaborations, and we work together in many different areas. So just a quick introduction to Chris as well. Chris Lee is the founder and the CEO of Oak Network. And again, Oak Network is meant to be the Stripe of Web3. So before founding Oak, Chris worked as a senior backend engineer at Microsoft and as a serial entrepreneur on several different ventures. During the past 4 years, he's led teams building prediction market smart contracts on Ethereum, gaming DApps on EOS, and the gaming DApps on the EOS network ranked in the top 10 daily volumes throughout 2019. So Chris and I are friends, and we also work together for Polkadot network events in San Francisco. And so I'm really excited to collaborate on a virtual event here with Oak and with Chris. And with that, I'm going to go ahead and hand it over to Chris.
Thanks, Kevin. Hi, everybody. Good morning, good afternoon, and good evening. I'm really honored to join this Moonbuilder Workshop. Thanks, Kevin and Moonbeam team for having me here. We have been in Polkadot space for ecosystem for about 2 years. I think many of you have heard of us. So today, Kevin said, well said for the background of Oak and myself. So I'll skip the intro. Basically, here at Oak Network, we want to build the infrastructure that equips developers like you guys with automation features for recurring payments, limit order, daily cost averaging, and auto buy on NFT markets. So I'll cut to the chase. We'll do some developer documentations today. I'll showcase how we work with the Moonbeam to schedule recurring payments. Basically, schedule recurring payments on Moonbeam. And we don't plan to build an EVM smart contract engine ourselves. So what we'll do is that we'll leverage the EVM on Moonbeam and Moonriver right now because we only have the Kusama parachain. Everything starts from Moonriver and everything ends at Moonriver. And you pay with tokens like Mover, or you can pay with Tur. Either is okay. So that's the developer experience we want to build. Everything, we don't have EVM smart contract. So if you want to serve Ethereum user specifically, if you want to serve users that who only has MetaMask wallet, you should connect to Moonbeam or Moonriver and kick off the transaction. But you also have the capability to ask a user to connect their Polkadot.js wallet. So set up a transaction from Turing or Oak directly. So either way is okay. We have both ways working. And today I'm going to show the Moonriver way, the Moonbeam way. All right, let's get right into it. Before we start, I encourage you to leave questions in the chat box. So if you got any question, feel free to ask me because this is a lot of material. So if you haven't done anything with XCM yet, this is a lot to digest. I'll try to stay at a high level as much as possible. So if anybody got a question, we can dig into the details in the Q&A sessions. Cool, let's get started. So today's goal is to see how to schedule recurring payments on Moonriver. Simple. So this is the lecture goals. So basically, we'll use Moonriver's extrinsic. We'll learn XCM. We will send XCM transaction from Moonriver to Turing network to schedule the recurring payments, and we'll learn how to debug what are the tools you need to use in order for the live troubleshoot. This stack will be shared after this workshop, so no worries if you miss anything. You can come back and check out the deck later. All right, so if you're a DApp developer, if you want to build something cool for it, or if you already launch an EVM smart contract and an application on Moonriver, what should you do? You should start by defining the product or features that you want to build. So today, our goal is simple. We want to build the recurring payments on Moonriver. So that's our product. But you also need to think about who you want to target, right? Who are those users? Do any of the user require any automation features on your product, right? Think about that. Define the product first. And we'll go down the list for the preparation, how to compose XCM, how to build the client code. So we use JavaScript. So at the end of the day, what we'll provide you with is a JavaScript code snippet that you can use that is out of box, that you can use to kick off what we learned today. So at the end of the day, it's just one command to you. But I need to explain, step by step, what are we doing, right? Not stealing money from your wallet or with your private key. All right, let's go to the first item, which is define the product. Today's objective is to schedule a recurring payment on Turing network by using Moonriver's remote execution. That's a big topic, remote execution, which has a list of sections in Moonbeam's documentation. And by the way, we're using Mover to pay for all the fees. So there's no Turing token involved. What we do is that we convert the Mover to Turing behind the scene. So users don't worry about that. The chains convert them behind the scene. First of all, this is the XCM. Remote execution means you're doing something with XCM. XCM is the cross-chain protocol, right? So your app deploys on Moonriver, and the remote execution means you execute something on another chain, cross-chain message. So we start by define, okay, where's my chain? If you're a DApp developer on Moonriver, your source chain would be Moonriver, and the target chain today will be Turing network. So we define that first to be clear of that. Also, the target extrinsic we're calling today is automation time dot schedule XCMP task. That's the recurring payment schedule extrinsic we want to call today. So let's be clear for that first. And I'll show you a very high level diagram to show you what the schedule XMP task does behind the scene. So let's take a look at the 1, 2, 3, only the 1, 2, 3 in these charts. First of all, your user comes to your app, and then you ask them to schedule a recurring payment, and they sign for it. They see the transaction, they sign for it. That's a 2. So the third step is that Moonriver will remote execute the schedule XMP task on Turing network. Basically, Moonriver say, hey, I got this user signature. I want to trigger schedule XMP task on your chain. And we're like, Turing network would be like, okay, you have the signature, you prove this from the user, we'll set up the task. And the task could be send money to somebody every day or every week. So today, we will only learn the step 1, 2, 3. And behind the scene, when the tasks are scheduled on Turing Network, every day Turing Network will send an XM back to Moonriver and tells Moonriver, your user set up this task to be triggered every day. So this is the end of the day. I'm going to trigger the user specified task right now. And Moonriver sees those proof, sees the request, and Moonriver will go execute whatever the task user schedule. Yeah, that's the basics. Simple, right? So the difficulty lies in the complexity of the XCM, because it's a protocol that built with great flexibility. That means you can do 1,000 things with it. But today we have a very clear goal. We have very simple use case, which is to do the recurring payments on Moonriver. All we need is a template, right? You have 1,000 ways to do things, 1,000 options. All you need is 256 gigabytes iPhone, right? 256 gigabytes. That's all you need. So what we have done is to look at all the options, and we have built a template with Moonriver, with the Moonbeam team, to offer to the developers. So end of the day, we'll provide you with a template which you can use to do the same thing that we showcased today. So currently what we're doing are building more and more templates. For example, if you want the NFT auto buy, you use that template. And if you want limit order, you use that template. So that's what Oak is doing these days. A few requirements. The first one, I'll just skim read quickly. The first one is for the chain developers. For example, you're saying, I'm on Akala. For example, your DApp is on Akala, and I want the recurring payment. Sorry, we haven't tested Akala, so the chain configs need to be compatible. Because it's 2 chains, those need to be compatible. Especially there's a thing called a barrier. It's like a law deny rule from the chains. So those need to be compatible in order to do these things. So Moonbeam and the Turing Network, Moonriver and Turing Network have been testing against each other for about 3 months now. So we know that we are compatible. That's for chain developers. So before you do anything, first communicate with the chains, and make sure they can support this remote execution. The second is on your shoulder, which is to ask user to set up proxy wallet for the XCM transaction. The proxy wallet concept is called account abstraction in Ethereum, which is kind of popular topic right now. But on Polkadot, the account abstraction is already a solved problem. So we'll show you, basically, you set up a proxy wallet, which has a very higher security implementation that only does this thing through XCM. So XCM cannot ask your proxy wallet to do all things. You can just specify a few categories. I'll show you later in the demo. Yeah, it's simple. It sounds complicated, but it's just extrinsic. Basically, you just call proxy, add proxy, and add your sub wallet to it. So basically, let's see if I can. Basically, let me show you Moonriver. You can allow this sub wallet to trigger things in these categories. You see, Moonriver has defined these categories very well. You can do any, or you can do governance staking. For example, you can do auto restake, although Moonriver has auto restake. You can do auto vote. You can do auto transfer, balances transfer, and something else. But today for transfer, actually, we can do balances. We can do balances. Yep. This is a preparation. And to this point, we are pretty much ready to trigger the XCM call. All right, compose XCM message. Moonbeam team has done a very good job by encapsulating and simplifying the XCM messages. You'll see in the in below, but all you need to call is a XCM transactor transact through signed extrinsic. This is the only call you need to do for the entire operation, like recurring payments. You only need to call this call. There are a few things, parameters need to be specified. We'll go over them later. This is a screenshot of the call. The first parameter is destination. For in this case, it's Turing network, because remember in the diagram, we're calling from Moonriver to Turing network, right? So destination is to Turing network. Of course, your source chain is Moonriver because you're talking to the Moonriver right now. And the second parameter is very important. It's the inner call. Basically, it says, okay, I'm sending a cross-chain message to Turing. So what Turing is going to do, right? So this inner call is that task, that execution. So I actually have a link here, which is very handy. So this is what Turing network is going to do when it receives your XCM today. So you can see all the parameters. It's pretty long. There are some details in it, so I'll skip all the details. But with this link, with this encoded call, you know that Turing network is going to execute that function, and that function is called schedule XMP task through proxy. And of course, you need to specify fees because you don't want the XCM, the Turing network actually doesn't know beforehand how much money, how many tokens will be spent for this call. It doesn't know. You have to calculate it. You have to specify that. The JavaScript code snippet we provide at the end of the day will auto calculate that for you. So here you just need to know how many tokens will be consumed. And weights is a little delicate limit to how many tokens will be spent. Also, the chain might have configuration to say, okay, you want to take like 2 seconds off from my execution time? No, sorry, no. So you can't execute something that takes too long. The destination chain will block you. So that's something to keep in mind. Sometimes you'll see an error like wait over limit. Basically, that means your call is taking the destination chain's time for too much time. So it's just something to keep in mind. But this will also be auto-calculated. Put above all together, we have this extrinsic on Moonriver. Let's take a look. So the call is XCM transactor transact through sign. So this is the call. It specifies the destination, which is Turing network. We're talking to Turing. It specifies the fees, and it specifies the weight information. As we mentioned, 3 items. So in reality, it's much more complicated than that. That's why I'm saying this extrinsic on Moonbeam and Moonriver have simplified the process. So you only need to specify 3 items. All right, so this is a bit of getting into the details of the XCM elements. I'll show you a little later. I have another example about this. All right, So basically, the call we just made from Moonriver to Turing network consists of the 6 steps, 6 instructions, which are descent origin, withdraw asset, buy execution, transact, refund, and deposit asset. So these 2, the number 2 and number 3, are used to pay for fees. So if we don't have enough fee, the operation will fail. The transact is the target execution for Turing network. Basically, it's the schedule functionality, and we have 2 instructions for refund. So if you pay too much fee, so a portion of the fee will be refunded. So 6 instructions, and once the call is constructed and submitted, there's a very handy tool I must mention from the Moonbeam team, which is called XM Tools. So the XM Tools provide you with script to interpret the XM send and receive at the target chain. So it has to be received. So if it's the send is not received, you cannot see this. But in this case, I already checked the network result. I know that Turing network has received my call, and I call this script to get the below trace. Where are the trace? Okay, it's in the next stage, next page.
It's super helpful for debugging purposes, right? Like if you're ever trying to sort out an XCM issue, just look at the message that was actually received, right? And then you can see, you know, if you provided the correct instructions, if you need to tweak anything, things like that.
Yeah, put a little later to the slides. So basically, this is the traces. Very super helpful. You see all the parameters, all the values embedded into the call, because like with the extrinsic call, you didn't see this. But here again, this is a template we have built. So you can tweak all the values you want, but this template works. So the best way is just to take the code and reuse the template. The 6 instructions I mentioned are all retrieved from the script here. So this is on-chain events. As long as you can see this, that means the transaction happened. The transaction, the XM message is received and executed by the destination chain. So this is success. All right, let's go back and continue. And client code. What I just showed you is done from the Polkadot.js, right? We saw the Polkadot.js app. You know, there are 10 parameters you need to specify. It's pretty tedious process if you want to do it every time manually, right? So we have prepared a JavaScript code for you to recall those transactions. So let's take a look. This is the XM demo in Oak repo, and we have the JavaScript code example for all 3 environments of Moonbeam. So local is for your dev machine, and Moonbeam have this Moonbase Alpha environment. We have the script for Moonbase Alpha and Moonriver. And it's very easy to use it. You clone the repo, you set up wallet keys in private folder, and you execute the following command. The command will remind you. So if your wallet doesn't have any balance, the command will fail and remind you of the account balance too low. So you have to top up your account. Keep in mind that every transaction needs tokens to pay for fees. So of course you need to have tokens in your wallet. And this is what it looks like to call the XM transact through signed on Moonriver. Remember, that's the only call we need today, right? But when you look at the code, in order to prepare this call, there are actually a lot of code before this. So what we are doing at Oak is that we're trying to simplify the process of making these calls. So we created a Oak.js library, very similar to Moonbeam's XM SDK, to simplify the process. So it's still in development, but we have all the packages, 4 packages created for making this call simpler. Right now it has 150 lines of code, but with the SDK, we're making like as short as 20 lines. And this is the output from the XM demo I showed you earlier. Let's take a look. This has very detailed steps of the XM message. So the first step is to set up accounts on Turing and Moonriver. Basically, it's making sure you have balances. If you don't have balances, you're not going to complete the below transactions. And we do a one-time proxy setup on Turing. So we mentioned early in the prerequisites that you need to set up the proxy. So this is to set up a proxy. The third step, the one-time proxy set up on Moonbase and Moonriver, is for the recurring payments, because it's a round trip. From Moonriver to Turing, you need a proxy here. And from Turing back to Moonriver, you also need a proxy. So this is the third step, is to set up the proxy on Moonriver. And then after setup, we're ready to execute an XCM from Moonriver to Turing. So this is the one call. And then we just wait for the task to execute. So basically this line basically is waiting for the task to be scheduled. And in this script, it didn't wait for the recurring payment to happen, but if you wait long enough, for example, an hour or a day, the recurring payment will actually happen. It's an XAM message going back to Moonriver to trigger the balance transfer or any Ethereum call on Moonriver. All right. Now you have built the you have the code to set up the recurring payments, and things not always work smoothly as you expected, right? So in software engineering, we all know that sometimes things happen in product environment all the time. So what do we do when bad things happen? We need tools to debug live. Right? This is very important. So I mentioned this tool, Moonbeam's XM tools, very handy tools to retrieve the XM message from both ends and examine the elements of the XM. Remember, there are 6 items that are in the XM. So any parameter values wrong, set up wrong in the elements, the call might fail because of those. And the best tool I found to correlate the message on the source chain, Moonriver, and the message on the destination chain, Turing network, is through Polkadot. It's a data indexing tool that allows you to put in a message hash to correlate the XM message between the 2 chains. Let me give you an example. Why do we need that? Because let's say you kick off a XM message on Moonriver, right? Like you know what block number this Moonriver, this message was sent over, because when you call the program, it returns the block number. However, you do not know what block of Turing received, in what block of Turing it received this message. So all you have is a unique identifier, which is called a message hash. Basically, on Moonriver, you see Moonriver says, okay, at a block of 1 million, I send over this message. There's an ID. It's a hash. So that's the only thing you need. And we need to find the same message hash on the recipient of Turing network, right? So how do we do that? Currently, we are leveraging this Polkadot.io tool. It's a data indexing tool. So we basically get the hash you put in. This one actually doesn't, this hash doesn't work. I already tried it. I have one. Okay, let me, for example, so this URL has a message hash. Basically, this is the ID of the message. And this tool will be able to correlate the origination, which is the source chain, like Moonriver, and the destination, which is a Turing network. And we can say, okay, Turing 3433400. Let's see what happens. So in this block, Turing receives this XM message. It goes back. And when you examine the XM message, it's exactly as we described. There are 6 instructions in it. Decent origin, withdraw asset, by execution, transact. Yep. So this is very handy. This is what we use to debug to correlate the messages in between the 2 chains. And the best way is to ask questions directly by reaching out in our Discord. You can submit a ticket, or you can just shout in the developer room, hey, I'm encountering this problem. What do I do? We have community manager. Juice is our community manager. He will answer your question right away. He's always online, 24/7. So he's great. Reach out to him. We already go over the instructions here. I'll mention a few common issues that will fail the transaction, because I see this a lot. Most common issues are because of fees. Either you paid not enough fee, or the weight of your call is too high. Basically, weight means the time and storage space the blockchain needs to consume to execute your call. For example, you write a loop in your smart contract, it will definitely run out of time because it takes forever to run, right? So that's a good example of a overweight. So very common issue you see is because of fee and weight. And the simplest thing you can do is trying to increase the fees to see if the call can go through. If it can go through, that means you paid insufficient fees in the previous rounds. And sometimes we see version mismatch. When XCM upgrades from V2 to V3, we see this error a lot. And I know XCM V4 is in development. So maybe early next year, V4 comes out, developer will see this error again. But right now, everybody's V3, I think. And second, including call issues. This issue is a little complicated because you can send whatever you want to the target chain and ask it to execute it. For example, you can say, I want to be the sudo of the target chain. I want to run some sudo functions. So that will definitely fail if the chain is well written. Because the execution in the XCM is just a payload, right? The XCM is a vehicle carrying your payload to the destination chain. The result is unknown unless the destination chain executes it. And the destination chain might have, strange configs. For example, it disallow this thing, disallow that thing. So when that happens, you have to first get the block number of the recipient of the XCM and check the subsequent events to see what happens afterwards. Let me give you an example here. For example, this is the Moonriver. This is my subscan. This is my XCM send transaction extrinsic to schedule the recurring payment. As we shown in the very first section, this is the XCM transactor call, right? This is the send call. And then I have the recipient event. So you send the call, you send the exchange XCM message from Moonriver, and Turing network needs to receive it. It needs to print out the successful event of the recipient, right? So here we can see XMQ success. So basically this is the acknowledge of the recipient of the XM message. And what it does next is to deduct the fees. It always deducts the fees first. And then what happens? It executes the payload. And the payload we mentioned is called schedule XMP task. And the acknowledge is for Turing network to emit a task scheduled event. Just saying, okay, I got your schedule XMP task extrinsic call. Now I'm emitting this task schedule. So you're all good. The task is set up and the task ID is this. So coming back, you should always see the successful execution of your XCM message on the destination chain. Let me give you another example. This is the recurring payment result on Moonriver. We mentioned that the whole purpose is to set up recurring payments, right? So end of the day, Turing send an XCM message back to Moonriver and say, okay, this user wants the recurring payment. End of the day, now I'm triggering it, and Moonriver receive the XCM message. What it does, it says, okay, XCM PQ success. I got the message. I'm gonna deduct the fee from your transaction. I'm gonna deduct fees, and we can see the fees are in Mover. And then what I'm gonna do, Ethereum executed, because for this particular call, we call the Ethereum smart contract. It's not a balance transfer. So it will run the Ethereum call and emit this Ethereum executed successful event. So end of the day, you always need to see a successful execution event on the destination chain. Once you have this is a proof that your call went through. And coming back to these slides, many times you see a failed call or the call didn't happen at all. So that requires a little bit of troubleshooting. Again, you can reach out to Oak Discord to ask questions. We can help troubleshoot for you. All right, that's all the content. So summary is that we explain how to schedule recurring payment on Moonriver. Under the hood, it's Turing network do the work. But in order to kick off the entire operation, you need to sign an extrinsic on Moonriver to schedule the call, schedule the job. And we have some instructions for you to check before you write the program. Again, the wrapped call on Moonriver is called XCM transact through sign. Another good example of the wrapped call is the common used X tokens transfer multi-asset call. It's another wrapped call of the XCM message. Remember, we have 6 message elements. in the XCM, right? So what the chain developers have been doing is to wrap them up, make it easier for the convenience of the developer or the user. So what Oak has done is to create a JavaScript SDK and JavaScript code example for you to take and to use that template right away. So both the way works. Currently, we're working on making the SDK more streamlined. We created 4 packages for it. So currently it's working. So if you're interested, feel free to check it out. And I want to mention that the time automation is actually in a pretty solid state. So feel free to come up with any automation feature and try to use it. Again, send us questions. We can help you solve any issues you see. We're currently working with Web3 Go, recurring payment dashboard, Yield Bay, Mangata auto compounder. So I can show you really quick, but this is Mangata. I will not show you in the Moonriver workshop, Moonbuilder workshop. And we're currently we're currently developing the price automation right now. Once that is ready, we can set up limit orders on Moonriver, which is very cool.
That's extremely exciting. And I love that you showcased and you mentioned that the SDK that you're working on, how you're simplifying. You said you're taking something that's pretty complicated and simplifying it into just a couple of parameters and stuff like that, just 3 or more. Was that right? Just 3 parameters?
Yep.
Yes, Juice, there will be a recording of the session. Yeah, we'll put it on YouTube. And it'll also be available right after this on Crowdcast, and then YouTube is usually like a couple days later. Cool. So I have a couple questions, Chris, to maybe kick things off. The title of this workshop is Recurring Payments, and it's also important to have decentralization, right? So I guess my question is, why is decentralization in recurring payments important?
Yeah. I think that the advantage of Oak over other app solutions in the Web3 world is actually on the security front. Basically, so some other solutions, if you are familiar with this streaming payment concept, they use a bot network to run your tasks. So basically, your task will be randomly assigned to a server in the bot network. So there's no one-to-one relationship. It's randomly assigned. But if you are familiar with the MEV concept, like when the server gets your request, it can still fuck up your wallet if he wants to, right? There's a penalty involved, but there's no guarantee that 100% that your task will be executed correctly or your funds will not be stolen, right? So what the benefits comes from the common substrate governance implementation that no to-do wallet in Turing network can fuck up your task, because we don't even have a to-do palette on Turing. Everything, like every change of the blockchain, need to go through the governance protocol, which is a very lengthy process. So if you're moving a lot of money of your Turing network, there's no way to quickly intercept your transaction and do something to it. Like there's just no way, right? Anything have to go through governance if anybody want to change anything. Also, it's code is law. The code is not run by the Oak team. The code is run by 26 communicators. We don't even know who will, like what validator will execute your task. It's all randomized. It's like Polkadot. Also, the security of a parachain is guaranteed by the market size of the relay chain, right? Nobody can intercept the XM message either, because that is guaranteed by the Kusama network and later by the Polkadot network. So it's just much secure. and much faster because we have all the block, we own all the block space of Turing network. And currently there are a lot of empty space in the parachains. So everything is so quick and so cheap. We haven't got to the point. I think the idea is that one block can fit 8,000, maybe 6,000 to 8,000 transactions per block. So we still have a lot of room for scaling in Polkadot.
I like that you mentioned that you brought it back to shared security. So obviously Oak is decentralized and is way more decentralized than those bots that you talked about. But then you're also mentioning that you have the security of the relay chain, of the Kusama relay chain and the Polkadot relay chain. So it's almost like an additional guarantee, as you said. So exactly. It's like a yeah. And we just got another question in the chat. I'm not sure, Chris, if you can see the chat history on the side.
Yeah,
this is from Cami. You can see? Cool.
Yep. Yeah, Cami is asking, is it possible to transfer the entire balance of an account using XAM? Yes, it's possible, but you as a DApp developer has to ask the user specifically whether they want to do that. And by default, we don't do that. For example, when you set up the proxy wallet that is used to execute the XAM message, you need to choose the categories, right? So unless you choose balances or any, they won't be able to move the token out of their wallet. So that really depends on whether you want to specifically do that for a user. And if you don't want that, it's by default it's turned off, right? If you want to do just auto governance or auto staking, there's no way to call the balance transfer extrinsic through XCM.
Cool. Awesome. And so going to like XCM use cases and stuff like that. What's one of your favorite Oak network to Moonbeam or Moonriver XCM enabled use cases?
Oh yeah, many. So we'll do the recurring payments first, and governance is another big topic because governance has a lot of usage in Polkadot. People love governance, and we want to do compound on the money markets applications. And when the price automation is tested, it's being tested. So the earliest launch is on September 20th, actually next week. Very exciting. However, that's on Shiden protocol, on Shiden network. We choose our swap reach out. They want to experiment that with us. So we're gonna, working with them as a guinea pig for the price automation, but test environment first, and we slowly roll out to the Shiden network. Once that is tested, we will expand that to Moonriver in a day. Because the logic, again, it's templates, right? We build the templates, it works for one network, it will work for the other.
That's awesome. I love that you mentioned governance because we have a bunch of initiatives around governance, particularly regarding delegation. And I think that there are a ton of use cases there because of things like if somebody's staking their tokens and they're gaining more, do they want to keep delegating them? What if they get paid and they have an increase in tokens, and do they want to keep going and redelegating them, or is there some sort of automation that they can do? And so I think that there are tremendous ways that we can make it easy for people to participate in governance without having to do a bunch of manual steps.
Yes, especially when you do governance, the token is locked into governance, right? So a cool feature would be once governance is done, you claim the token back and do something else. Yeah. We are also working
unlocking,
on
vote unlocking.
Yeah, unlocking. So the next month we are working on this dashboard where we're basically going to put all the use cases to this dashboard. Like governance could be one small feature for the dashboard, automation dashboard. So users can use it right away. Let's see a
So it looks like
question.
Nikolai has a question. Yeah, on the right side.
Yeah, do you believe XM itself should or could be simplified? That's a question to Gavin Wood, not to me. But I just went to the PBA course, which is called Polkadot Blockchain Academy, hosted at the UC Berkeley, and Gavin taught XCM for a day, maybe 2 days. I think the current direction we're going is to make it flexible, generalized and flexible. But that's very fine to me, because if you think about the protocol needs to be flexible, right? It's not an iPhone. The iPhone is a user-facing product. So if the protocol can be generalized, we can build an iPhone on top of the protocol. We can add layers like SDK or even demo website on top of it, right? As long as the demo website is simplified and built with a template, developers should like use it out of box. So actually, I think the protocol needs to be generalized and flexible.
And thank you, Chris. So in terms of like looking ahead, right? You guys are always building, and you mentioned the SDK. You have lots of stuff coming up. What are you excited about? And is there any sort of like forward, future stuff that you can share with us?
Yeah, we actually are looking for developers to add recommendations and maybe fix some small issues to our GitHub repo. So the first step is to check out the GitHub repos. We have the XM demo repo in these slides. I'll add our Oak.js SDK repo to the slides too and share with everyone. Also, I know like Moonbeam and Aster both get a lot of community PRs, right? Like that's pull requests for code optimization. So we just got one from community yesterday, the day before yesterday. It's great. I think being an open source infrastructure, we actually love the community support because you want to keep open-minded, right? We have so many community developers. Everybody have their own ideas. We want to see as many open-minded ideas as possible, not just us building the SDK, the infrastructure, because the developers are all users, and the users very often can provide very good feedback.
Absolutely. So Chris, you guys hosted the like a party for Stanford Blockchain Week, right? You hosted for the Polkadot Blockchain Academy. You've been very involved in the community, and it sounds like you're also participating in some mainnet activities next week. Can you tell us about what's going on around mainnet and Oak?
Yeah. The PBA party we hosted with the Moonbeam, it was a blast. Everybody liked it. We had about 170 attendees for the evening, which is pretty great for San Francisco meetup these days. And next week during mainnet, I'll be at New York next Thursday and Friday for a coffee workshop with our Oaks investor, Electric Capital. So it's hosted by Electric Capital with a bunch of portfolio companies. So we'll be there. So if you live at New York, if you are up for a chat, just feel free to come to the coffee shop. And free coffee and a bagel, which are great.
Oh, that's amazing. And that reminds me that the Electric Capital report is coming due soon. At the end of this year, right? So if anybody wants to contribute to that is open source. And so anybody can add repos and identify apps and projects that are built on Moonbeam, on Oak, on Polkadot, all these different ecosystems, and it helps inform the community. It helps, and that's all my pitch that I'll give there. But it's a great public service that they do, I think.
To second Kevin, Polkadot has been the number 2 years in a row. We higher than the rest of the projects like Solana, Near. So there's no doubt that we will still be number 2 this year, but we need to catch up to Ethereum.
And it takes into account, I think, sub ecosystems. So, for example, Moonbeam is a sub ecosystem of Polkadot, and then you could have, like Stell Swap is a sub ecosystem of Moonbeam or things like that. And so all the projects kind of get rolled up, into the larger ones, I think. So yeah, so I'm excited to see that for this year. So yeah, any other questions in the Discord or in the chat on the right hand side? I think that looks like it. Cool. Well, Chris, this has been a whirlwind learning session, extremely informative and polished.
Thank you.
You've presented this type of material before. You're an expert on this, and thank you for coming and sharing it with the Moonbuilders community here today.
Thank you, Kevin, for having me. I just want to say the XCM programming is actually pretty difficult, but Moonbeam has the best documentation. I actually have the link in the slides to the section of calculate derivative multi-location account, which was not mentioned in this slide. But if you run the XCM demo that we prepare you for, it will go through. You will schedule recurring payments. But if you want to learn more, definitely check out Moonbeam's documentation.
Here's the link for the calculate multi-location derivative account. So I just dropped that in there. And will the slides be available? I forget if we answered that question.
Yes. I need to export it into PDF and share with the community. Yep.
Oh, amazing. Okay, cool. Thank you so much, Chris. We'll add that to the
Kevin.
replay. We'll add it as a link. Thank you, everybody, for joining us, and look forward to seeing you in the next one.
Bye.
Thank you so much,
It's
Chris.
fun.